All right, we are on 2.5, model direct variation. So I'm not sure if you guys have heard the term direct variation before, but essentially it's just being able to say that the variables x and y vary directly and have a constant of variation. So the equation y is equal to ax represents direct variation between x and y and is said to vary directly with x. The non-zero constant a is called the constant of variation. Okay, in a graph, okay, if we're looking at a graph of direct variation, a is the slope and the y-intercept is equal to 0. Okay, so there's a couple things that I learned last year that I need to make sure we understand. So not necessarily doing examples per se here in the notes, but I want to talk about something really quickly with identifying direct variation. Okay. If I want to know if the equation represents direct variation, I need to look at a couple things, and it needs to be written in the form y is equal to ax. Okay, if there's anything other than y is equal to ax, then it is not direct variation. Now, a can be negative, okay, but there can't be anything added on or subtracted to over here. So if I were to just tell you y is equal to 10x, okay, this would be direct variation. Okay, because it's in the form y is equal to ax. Okay, and the constant of variation, okay, if you want to call it COV, that's fine. Okay, but it would be 10. Okay, whatever A is the constant of variation. Now, something I'm going to point out. If the problem is not direct variation, then there's not a constant of variation. So there's only a constant of variation if it is direct variation. Okay, something like y is equal to 7x minus 3. Okay, is this direct variation? Well, does it have the form only y is equal to ax? Okay, it does not, so it is not direct variation. Okay, and if y'all want to represent that as dv, okay, you just need to say not dv. Okay, that's fine. Or if it is, you can just say dv. Okay, that's fine as well. So this one does not have a constant of variation because it is not of the correct form. One more example of this And then I think we'll pretty much be done with this, other than in-class examples. If I have 4y is equal to 9x, is this direct variation? Well, I can divide y by 4 to get y is equal to, or I can divide both sides by 4, 9 over 4x. So this is still in y is equal to ax form, meaning that it is direct variation. Okay, so that's the first thing. My constant of variation, k, is whatever a is. A is everything in front of x here, which is 9 over 4. Okay, so if it is direct variation, you'd have to tell me what the constant of variation is. If it's not, you just say not direct variation. Let me see if there's anything else. I think for the most part, the rest of this we'll just go over in class when we get there. We can do this from looking at a table. We can graph the line of direct variation, stuff like that. We can tell if the variables vary directly. We can say, okay, we know that they do, so then we can find the different values given one or the other of the variables, things like that. But the big thing is I want to make sure you guys can tell the difference between direct variation and it not being direct variation, because if you can do that, then that will help significantly in doing these problems.